That was really cringy.
Particles. They're these weird things that make up our Halloween candy, my kendamas, and Noah's foot. By the way, this is actually a picture of Noah's foot. Today, to help me demonstrate the particle theory, I'm going to be using a glass of water. Now, for something to be made of particles, it must have matter. And for something to have matter, it has to have two things. It has to take up space, and it has to have weight. And if I go like this, as you can see, it takes up space. And if I lift it up, it has weight, clearly. It's like heavy. Now let's say these magnets are particles. They would be a solid because they are all very close together. Well, they're touching, but that's what a solid is. Solid particles, or particles that make up a solid, are very close together. These would be a liquid. Because liquid particles, or particles that make up a liquid, are less close together. They're much farther apart than solid particles. Now this would be a gas. And gas particles, or particles that make up a gas, are very far apart. And as you can see, it's taking up my entire island. Most of it. So this would be a gas. And no matter what state of matter they're in, particles always seem to be triggered because they're always vibrating and shaking. And the only way to untrigger a particle is through absolute Kelvin, which is negative 280 degrees Celsius, which is like colder than these pancakes. Now, the next law of the particle theory is when particles slow down and speed up through cold and heat. So to demonstrate, I'm going to be cooking ice on my stove with adult supervision. So everything's ready. I've got more ice, and we're turning this on high, and we're gonna see if it eventually will turn into a vapor. Now, as my lunch is cooking, I'm going to explain what heat actually does to a particle. Imagine this one right here in the middle. This is the internal element of heat. This is heat. And all the ones on the outside, they're still particles. Particles, they don't like heat. So they go like this, and they back away. But what happens when particles get farther apart, they change states of matter. So, we've pulled them all apart now because the heat has turned the liquid into a gas. And with this, you can already see it's melting a lot. But with this, it's turning the ice into water, and then eventually the water into vapor. Okay, so this has happened. So it's making a really cool noise. There's a lot of steam on my microwave right here. As you can see, there's a lot of like condensation everywhere. And we can't let this cook all the way out because once there's nothing left, it's gonna start burning the pot. So we're gonna dump it out, but as you can see, that's what happens. Now, I can't put my phone in the freezer and put it on video because, first of all, my phone would probably die and it would get too cold and couldn't run. And second of all, that would take way too much storage. So I can't film water freezing to ice, but I can get ice. But since everybody already knows that ice is from water getting cold, I think I'm just gonna skip straight to the particles attract. Okay, particles attract. So, we already know, these are all particles. And particles attract. Just like that. Special thanks to my kitchen, my magnets, my stove, Mr. Glass of Water, all the ice. I also just realized that I have so much ice in the sink melting away that I could have just dumped the boiling water from the last experiment on there, but meh. Thanks to me, and a very special thanks to Noah's Foot.